Okay, so today we're gonna finish up 1.2, and today all the examples that we're going to do are gonna involve fractions. So first thing what you should do is we're gonna eliminate the fractions. And then whenever there's a variable in the bottom, the denominator, we need to check our answers for extraneous roots. So what we need to do is make sure that when the answer we get doesn't make the denominator a 0. So the way that we'll eliminate the fractions is we're going to multiply each piece of the equation by the LCD, or the common denominator. So let's just try some examples. So this is similar to what I've already done. I'm going to look for the common denominator between 3 and 4. So I'm going to go ahead and rewrite the problem. So I have x over 3 plus 3x over 4 equals 2. You know what? I need to quick send. Let me check something here real quick. Let me just send this attendance real quick so they don't email me. All right, sorry, let me go back to this now. Okay, so what we're gonna do is multiply each piece of this by the common denominator, or LCD, which is gonna be 12. Now, you can do it two ways. If you'd rather just show that you're multiplying the entire equation by a 12, you can. If it's easier for you to write a 12 next to each one, you can do that also. Because what we're going to do is try to simplify things here. Now, we're not doing it like when we did the expressions, where we had to, whatever we did to the bottom, we did to the top. We're not trying to create a common denominator. We're trying to eliminate it. So we're multiplying everything by that LCD, and then I'm going to try to start simplifying. So 12 divided by 3, I get 4. And then 4 times x gives me 4x. Then I'm going to come here. 12 divided by 4 is 3. 3 times 3x is 9x. And then nothing to simplify here. I just do 2 times 12 and get 24. Now I solve my equation. I'm going to add these. Divide by 13. And x equals 24 over 13. I'm okay with you leaving it improper. If this were 24 over 12, I would reduce it to a 2. Now, the only time we need to, the check is mandatory, is when there is a variable in the denominator. There is no variable in the denominator, so I can just go ahead and this is the correct answer. If you want to do the check, you can, just to make sure that it works. But you don't have to when there's no variable in the bottom. Let's try number 2. Again, I'm going to rewrite the problem. I need to find the common denominator, or the least common multiple of each piece. And again, this time it's going to be a 15. So again, if you'd rather just write it and then distribute it to each one, you can do that. I'm going to write it right next to each other so I can see how it cancels. So this one, 15 divided by 5 is 3. And then 3 times 2x is 6x. Here, nothing simplifies, so I actually have to multiply 15 times 5x and get 75x. Here, this will simplify, and then 5 times 4 is 20. I'm going to group my like terms. 6x plus 75x is 81x equals 20. Divide by 81, and x equals 20 over 81. Some of these fractions aren't going to be very pretty. They're going to be huge numbers, and just don't think that it's wrong. Again, no variables in the denominator, so it's not mandatory for me to check for an extraneous solution. Let's try number 3. Same thing here. I'm going to find the least common denominator. I'm going to rewrite the problem so I have enough room to write each one. If you want to change this to a keep flip change, you can. You don't have to, because we're only have one term there. So now my common denominator is going to be a 10. So I'm multiplying each piece by a 10. And now I'm going to simplify. So 10 divided by 5 is 2. This becomes a 2x. Here, 10 divided by 2 is 5. This becomes a negative 5x. Nothing to simplify here. This becomes a 30. These actually cancel away, so I'm just left with the 3x. I'm going to simplify my left and get negative 3x. Equals 30 plus 3x. Move the 3x. Negative 6x equals 30. Divide by negative 6. And x equals negative 5. Let's try number 4. Here's my first problem where I need to check. Now, the only thing that would make these denominators 0 is if x equals 0. So if when I solve this, if I get x equals 0, then I throw that out, okay? So again, I'm going to go ahead and rewrite it. Find my common denominator. Between 1 and x, it's just going to be an x. So I'm going to multiply each piece by an x. And we could add this negative sign here to the 4 if you want. This cancels, so I'm just left with 15. Nothing cancels here, so this is negative 4x. I could even just do subtract. Let me just... 15 minus 4x. This cancels. I'm just left with a 6. Nothing cancels on the last one. It just becomes a 3x. I now need to group my like terms. If you want to move the 4 over to the right, you could do that instead. But I'll move the 3x over. Keep my letters on the left. Move the 15. Negative 7x equals negative 9. Divide by negative 7. Negative divided by negative is a positive. Now, because I did not get a 0 as my answer, if I were to take 9 over 7 and put it in the bottom of the fraction here, it doesn't make it a 0. It just makes it 9/7. So 9 over 7 is a good answer. It works.
Miss Corey?
Yes.
What did you say if x equals 0? You said something that I forgot.
Then it would be an extraneous solution.
Okay.
We're going to see that when we get to example 8. Hopefully I'm going to have enough time here to get through all these. Otherwise, I'm going to finish this in a video. All right, next one. I'm going to treat this as a proportion. Or what you could do is multiply both sides by 5x plus 6 over 2. Whenever I have just two fractions equaling each other, this is another way you can solve this, is just do cross products. So this times this gives me 2 times 10x plus 3, And then this gives me 1 times 5x plus 6. Distribute, and I get 20x plus 6 equals 5x plus 6. Move the 5. 15x plus 6 equals 6. Move the 6. 15x equals 0. 15, divide both sides by 15. 0 divided by anything is 0. So now, just because I got 0 as an answer doesn't mean it doesn't work. Because remember, what we're plugging it into is this right here. So if I take 5x plus 6 and put a 0 here for x, I get 5 times 0 plus 6. This gives me 0 plus 6. It doesn't make the denominator 0. It makes it a 6. So this answer is good. 0 is a valid answer on this one. If this were just an x down here, then you would throw it away and say no solution. Okay? Because you can never ever have a 0 in the bottom of a fraction. Let's try number 6. So now we have expressions. So what we're going to do here is our common denominator is going to be both of these. Let me rewrite the problem. I need to multiply both fractions by both pieces, not just what it's missing. So x times x minus 5, and even the 0 here. However, anything times 0 is 0. But just remember, every piece gets multiplied by that common denominator. So now, again, I look for things to simplify. The x's cancel. So then I'm just left with x minus 5 times 1. The second fraction, the x minus 5's cancel. So then I'm just left with 2 times x. And then the end, 0 times anything is 0. And now I solve. I combine my like terms. I'm going to move the 5. And 3x equals 5. Divide by 3. And x equals 5/3. Again, what I need to do is make sure that it doesn't make anything a 0. So when I plug it into this one, 5/3, it doesn't make it 0. But when I plug it in here, x minus 5, it still doesn't give me a 0 when I try to subtract this. I don't have to do the problem, but the only way I would have gotten a 0 is if x were a 5. So this is a good answer. It does not make anything undefined. Let's try number 7. My common denominator is going to be both of these. So let me rewrite the problem with enough room to squeeze in both. And I'm going to do a keep flip change here, make this a negative 8x at the top. So now I need to multiply all three pieces by x plus 2x plus 1 and 2x minus 1. All three pieces. And now I look for things to cancel. So the 2x plus 1 cancels. So now for the first fraction, I'm just going to distribute a 7 to the 2x minus 1. Then for the second fraction, the 2x minus 1 cancels. So now I'm left with distributing a negative 8x to the 2x plus 1. This last one, nothing cancels. So now I have to multiply negative 4 times 2x plus 1 times 2x minus 1. So I got to FOIL that, either distribute first and then FOIL. So let me just start at the left. I'm going to distribute the 7. 14x minus 7, distribute the negative 8. I'm going to distribute the -4 first. And then I'm going to FOIL it with this one. Now, if you would have rather FOILed the two things first, you could. And now I got to FOIL these two. So this gives me -16x squared plus 8x minus 8x plus 4. These cancel. So now this is just leaving me -16x squared plus 4. Over on this left side, I'm going to group these two, and I get 6x minus, not squared, 6x minus 16x squared minus 7. Hi. I think it's resolved. Girls, you got internet back? I'm sorry?
Yes.
Yeah, they had lost it, but then I guess that was in the process of everybody losing it.
Good, yes.
Yes.
We got a problem at the 30 minutes ago. All the school.
Yes. Okay, we're good now.
Yeah,
Thank you. Okay. So now I have to start grouping my like terms. I can add a 16x squared to both sides. It's gone from here. And now I get 6x minus 7 equals 4. I know that's kind of hard to see. 6x minus 7 equals 4. Add the 7. 6x equals 11. Divide by 6. And x equals 11 over 6. Now I got to check this because there were variables in the numerator. Now, what we'll do is we'll put it up here. So when I do 2x plus 1, and if I put in 11 over 6, this isn't going to give me a 0. It's going to give me another number. Same thing if it were here. If I plug it in, this is also not going to give me a 0. One other way that you can do to check for extraneous solutions, you could take your denominator and make it not equal 0. And this is another way. So if x ends up equaling -½ or +½ then you would have thrown away the answer. So that's another way you can do it instead of having to plug it in. All right, let's try number 8 because it'll actually fail on number 8. And the bell's going to ring, but let me see if I can get through this. So my common denominator is going to be this. So I'm going to multiply each one. Let me see if I can rewrite it. So x minus 2 and x plus 2, because that's what this factors into. So I'm going to multiply each fraction by that. And then the 6x, and I made it negative because I did a keep flip change. All right, so all the black is the original, and then the red is that common denominator. So now these cancel, so then I'm here just left with x plus 2. This cancels, I'm left with distributing a 3 to the x minus 2. Both of them cancel, so I'm just left with, and there should be an equal sign here, not a plus sign. So I'm just left with -6x. I'm now going to distribute 3x minus 6 minus 6x. Combine these like terms. -3x minus 6. Move my x's together. And then I get 4x plus 2 equals -6. Move the 2 by subtracting it. Let me do yellow so it shows up a little better. 4x equals -8. Divide by 4, and x equals -2. Now, if I go up to the top and I plug in -2 into this one, Notice if I do x plus 2, just pick one of them. As soon as it makes one of the denominators a 0, this answer is no good, and my answer here is no solution. It's an extraneous solution. So there are actually 4 more examples. Whatever I don't finish, I'm going to finish in the video, but it's just more of the same. So you do have an 8-question web-assigned homework that's due on Monday. You're going to either right-click it, save it as a PDF, do the work right on there, and then screenshot your score. Or you could just rewrite the problem on paper or on a blank notability file, and that's how we're going to do homework. And then you can just look at the rubric to see what kind of grade you would get. As long as you get an 80 or higher on the WebAssign, you get 100 for Canvas as your homework grade. You can retake the assignment 3 different times. Don't rely on your friends to give you the answers because everybody gets different problems. Okay, same format but different numbers. All right, let me see if I have time to do the next one. So here my common denominator is the x minus 4. So let me just rewrite my problem. 5 over 1, 12 over x minus 4. I'm going to multiply everything by x minus 4. This one cancels. I'm left with 3x. This one doesn't cancel, so distribute. This one cancels. So I'm going to distribute the 5. Rewrite everything else. I can group these like terms. This gives me negative 8. Move the 5, the 5x. And then I end up with negative 2x equals negative 8. Divide by negative 2, x equals positive 4. When I plug in that 4 up here, 4 minus 4 is 0. That's a bad answer. This thing is no solution. So my advice to you is when you take this test, if you only can get to the solve part and you forget to check, you're not going to lose all the points. So just keep that in mind. All right. So that's it. I will complete the last 3 on a video. You can watch it if you need to see more practice. Okay, so for the next example, we need to find a common denominator. And our common denominator is going to be x minus 1, x plus 3. So let me go ahead and rewrite my problem. So 12 over x minus 1, x plus 3 equals 3 over x minus 1 plus 2 over x plus 3. Remember, we want to eliminate the denominator, so I'm going to multiply each fraction by that LCD. So let me go ahead and fill that in next to each fraction. And now I'm going to look for things to simplify. So the x minus 1 and the x plus 3 cancel, so all I'm left with here is the 12. The second fraction, I can simplify the x minus 1, and now I have to distribute the 3 to the x plus 3. The last fraction, the x plus 3 simplify, and now I can distribute the 2. So now I need to distribute 3 to the x, 3 to the 3, 2 to the x, 2 to the negative 1. Group my like terms. And then I have like terms here with the 9 and the negative 2. And now I can begin to solve. Subtract 7. I get 5 equals 5x. Divide by 5. X equals 1. Now notice I do have variables in my denominator. So if I take my answer and I take it and substitute it or plug it in to the x minus 1 or the x plus 3, notice as soon as I plug it into this one, I get 1 minus 1, which would make this denominator a 0. It would also make this one a 0. So my answer that I just got is going to end up being no solution, because x equals 1 is an extraneous solution. So you're going to put the circle with the slash. So this is an extraneous solution. So it's no solution. It makes the denominator a 0. 2 more examples and we're done. So I need to factor the first fraction's denominator. So this is actually going to become x plus 3, x minus 2, which you can see you already have in the first 2 fractions. So let me go ahead and rewrite my problem and leave enough space so I can put that LCD in there. So again, my least common denominator is both. So x minus 2, x plus 3. I'm going to write it next to each one so I can make it easier for me to cancel. So my first fraction, the x minus 2 cancels. 1 times x plus 3 is just x plus 3. My second fraction, the x plus 3's cancel. I need to distribute the 3. And then the last fraction, everything cancels because that was the factored form. Now I can combine my like terms. 1x plus 3x is 4x. Okay, so then I'm going to add. Okay, so now I also need to combine my like terms of 3 minus 6. And then this gives me negative 3 equals 4. Add 3. 4x equals 7. Divide by 4. And x equals 7 over 4. Now I need to make sure that this isn't an extraneous solution. If I plug in 7 over 4 here or here, it's not going to make either of these a 0. So 7 over 4 is a good solution. And then again, I have one more example. And again, I can go ahead and find my common denominator. It's actually going to be this. But I'll go ahead and put it in as x times x plus 3. So let me go ahead and do this in red. So the LCD is x times x plus 3. And let me rewrite each part of the fraction. And then again, put the LCD up here. And then again, this last piece, 3x plus 5 over x squared plus 3x. So for the first fraction, the x's cancel. So then I'm left with 6 times x plus 3. The second fraction, the x plus 3's cancel. So I'm just going to multiply negative 2 and x. And then the last fraction, everything cancels because again, this distributed to what was already down there. So then the numerator is the only thing that's left. Let me distribute the two ends, 6x plus 18. And then I can make this minus 2x, 3x plus 15. Group these like terms first, 4x plus 18. Move my x's together. And then I get x plus 18 equals 15. Move the 18. And I get x equals negative 3. So again, remember we need to check it. So if I take my denominator, which is either the x or the x plus 3, if I put a negative 3 in here for x, it just becomes a negative 3. But if I put the negative 3 in here, negative 3 plus 3, this becomes a 0. So this denominator would be a 0. So this answer I just got is extraneous, so this is no solution. So this is an extraneous solution, so I will not include it as an answer because it makes my denominator a 0. So that is it for your examples with fractions. Again, you have your WebAssign homework. There are 8 questions and it's titled 1.2b.